So, first off, thanks to all the Bluehost folks who are here, and extra thanks to the non-Bluehost folks who are here. I recognize a few of you. Non-Bluehost, raise your hand.
So you know who you can hire now.
So besides wanting a job, would any of you guys like a free dedicated server for a month? Or free VPS? Come and hit me up afterwards. I got cards. Got magic. Okay, so making your awesome code awesomer. First off, your awesome code. This is how it all works out, right? It's beautiful, visually stunning, and does everything it was meant to do exactly. Or sometimes maybe it's more like this. This is the, this is awesome stuff, isn't it? This is beautiful code that somebody wrote at some point that they thought was super awesome. It doesn't really matter who. But then somebody else has to maintain it, right? Somebody else has to come along and they have to, you know.
Are you going to profile that?
No, I'm not. That would be fun. But somebody else comes along, your coworker, Fred. We all know who Fred is, and tries to add some new features, make it more flexible, or add some extra things, and it's kind of ugly. It's just getting worse. It's tacking on more things. And then your boss comes to you and he says, dude, remember that thing you wrote like 12, 18 months ago that was so awesome? It sucks. It's not working for our new use case. It's not doing what we tried to have Fred make it do. And Fred says it's all your fault because, you know, you didn't optimize it enough. Your code was sucky. Or this is a little bit more of a case I've actually had to deal with. You wrote it expecting this range of parameters, but now you need to be able to handle this, and now it's timing out, and your code sucks. And you don't know what's wrong. You don't know why it's slow. It worked great for the last 3 years, but it's been getting slower and slower as your company's been getting bigger and bigger. Customers have had more domains or more of whatever it is you sell, and so now you need to do something. So how do you figure out why it sucks? How do you figure out why it's slow now? I mean, you could just blame it all on, you know, old hardware. We're still stuck running an old version of Perl or whatever, but your boss isn't going to be happy with that, so you got to start digging into it. Everybody's favorite Perl debugging tool, print statements. Print this, print that, toss in a little time high res. Maybe I can time how long does this statement take, and that statement, and I'll print it out. Maybe I'll even log it to a database somewhere. Then I can query over it or, you know, whatever. But this is ugly. This is a hack. You've got to pull it back out in order to actually commit your fixes and your changes, and it's hard to keep track of. And so you may have in the past, if you've been in Perl for a long time, you may have run into Devel DProf, Devel FastProf. These were older, and there's a handful of other ones too. The number of older attempts at profiling Perl code to break down how long you're taking in each of the various sections of your code. But these aren't very great. They mostly give you command line text output that you've got to parse through a bunch of gibberish that you barely understand and figure out what's going on. So Tim Bunce, who's an awesome guy in the Perl community, has made a lot of cool things. He was Pumpkin for a while, way back in like the 5.4 days or something like that. Only Curtis still remembers those days. He was working at New York Times and trying to figure out why some of their code was having these problems. Why was it slow? He was using Devel FastProf and was just frustrated with some of the bugs that it had, some of the inconsistencies in the timing, the fact that it was often influencing the timings itself and not giving you more than just statement level. So how long did this statement take, not how long did this subroutine take, or how long on this statement, how much time was what was happening on that line versus how much was, you know, in the method I called out to that happened somewhere else. So he started working on NYTProf, and there have been several iterations over the years. But NYTProf's focus is to make it much easier to drill down into your code and really look at what's slow, where are the bottlenecks, and give you a lot of information that you can make use of to facilitate figuring out. And obviously, you're going to know your code. It doesn't just say, here's your problem, change this line, and you'll be done. But it tells you a lot. It gives you a lot of information that you can analyze and figure out, what can I do to make this better? And the reporting is a massive improvement over the old Devel FastProf days. Whoops, wrong laptop. Wrong. So how do we actually run NYTProf? So the simplest, quickest way is you run on the Perl command line, -d:\NYTProf. The capitalization on there is a little bit tricky, capital P, lowercase r. I mess that up every time. But, and of course, you've got to have Devel NYTProf installed, but it's pretty commonly installed. I think CentOS has it by default now. And then you just run your code. And so it'll run your code, and it'll give some output, and you have to do some processing I'll talk about in a second. Of course, most of us aren't just running Perl from the command line. So you've got this as an option. If what you can debug is something you can just run from the command line, you're good to go. If not, we've got two different ways that you can get this into your Apache config and actually run this as part of Apache. So there's Devel NYTProf Apache that really just kind of does it all for you. It's pretty nice. If you're in an environment where you kind of have to hack things or you don't have that module installed and it's not easy to do so, then you can kind of do it a little bit more manually yourself. Just put these two lines into your Apache config, and you're good to go. At least in the sense that it's going to profile all of your Perl that gets run through Apache. So again, maybe some limitations in doing that. I'll get to a solution to that in a second. But you've also got a whole lot of options. And this is just a slice of some of the ones. Oh, and sorry about the capitalization on Sig Exit. Auto correct on Impress. These are just a few of the options you can pass in. Go read the documentation for all the rest of them. But you can change the location. So this is a common problem with if you're running it, say, in Apache. You can't necessarily write to what would be the default working directory. So you can change it to, say, temp or something like that so you can output. Add PID, we'll just use this as your output name. So instead of nytprof.out, you get nytprof and your PID.out. That's also helpful for things that fork, because then you'll get a different file for each forked process.
Like in Apache, you might have two different bits and you don't want them all in one.
Yep, you'll get them in two separate files. Now, it's not going to give you a whole lot of information about which hit went where, but we can talk about a solution to that in a minute. Then there's a whole bunch, and I just picked out one, the subs equals 0. There's a number of different types of profiling that are turned on by default. You can turn them on and off as you want to, depending on your needs. You can turn on and off the clock that it uses, so you can kind of fiddle with how it's doing the timings. Sig Exit is one I've had to use before. Sig Exit equals 1 makes it that NYTProf will attempt to catch things like Sig Int and Sig Hup. Because if you kill your running code while NYT is profiling, it doesn't get to clean up and finalize its output file, which is this big binary thing. And so you can't actually do anything with it because it just got truncated and it's dead. So Sig Exit is NYTProf's attempt to catch it if you need to. If you have something that's running for a while and you just wanted to profile it for a bit, and you don't know why it just keeps running forever and ever, and you want to be able to Control-C out of it to kill it and still be able to time it, Sig Exit is the solution. And then start equals no. This is the nice solution to, I don't want to profile everything. I want to profile this method or this subroutine, this piece. And so start equals no tells NYTProf, don't load everything up, get ready to go, but don't actually start profiling until I tell you to. And then if you're doing it on the command line, this is how you would actually get this into your environment variable, the simplest way anyway. And notice the little bit of goofiness of the double equals, but it works. Yes, sir?
Flag for start no, is it something you can place in the code?
The start no, no, these are all things that you could put right here.
How do you turn it on once you've done something?
That would be the next slide. So let's say you've got something running in Apache, you've got net server, you've got whatever your long-running daemon is, and you only want to profile a piece of it. So you need start equals no to get your NYTProf set up and running, but not actually doing any profiling. And then it's simply db : enable profile. And then you can, if you kind of want to start and stop for different pieces, you can disable as well, which is just a temporary pause. And then you always need to run db finish profile. Technically, NYTProf sets that up in an end block, so it will run it for you. But if you're in a long-running daemon, you may never get to that end block. And so you probably want to do finish profile. Because again, if you don't run that, your output file won't have the finalizing data in it. Because NYTProf keeps a lot of stuff in memory while it's running in order to speed itself up. And so you don't get that dumped out to disk unless you run finish profile. All right, so let's talk about the output a little bit and what do you do with it. So the output is nytprof.out. I shouldn't have tossed that slash in there, but it's in whatever your working directory is by default. Again, you can change it as I mentioned. It's a big, massive binary file, so you can read it all you want, but it's going to be total gibberish until you actually process it. NYTProf comes pre-installed, or as part of the install, with a number of reporting options. NYTProf CSV, which I think might actually be deprecated now, but there's an NYTProf CFG, which goes into some output that I haven't ever used. NYTProf HTML is my favorite by far. It makes for awesome output, really, really nice reporting. Anybody in here ever used Devel cover?
Yeah.
Okay, so you'll recognize the output. It's Devel cover, it's output essentially. And also, again, NYTProf HTML assumes your working directory for the output file, and just that it's named nytprof.out. So if you used Apache and you added the PID or you put it in temp, then -f is your friend. And then that will generate a directory, and you'll actually, in the live demo, you'll see an example of this and what to do with it. But it generates a directory that's called NYTProf that has potentially hundreds or thousands of HTML files in it, depending on how much of your code it profiled. And you've got to shove that directory somewhere where you can view the HTML that's in that page, or in that directory. So, live demo time. Don't curse me before I've started, Rob. Come on. OK, so let's take a look at some fun code. Let's make that bigger. Is that readable? Oh, yeah. OK, so I'm sure everybody has seen bad examples of Fibonacci code. It's a favorite example of, let's write really bad code from the beginning so we can have an excuse to optimize it. So I did the same thing. So we've got a bad Fibonacci method here that just does the recursive form of Fibonacci, and it's incredibly slow. And down here, I just run it 30 times for each number, so we can actually time this. Oops. And see that it's a little bit painful. I cut it off at 30, so I wouldn't be standing here waiting for it to finish. So almost 2 seconds to run through the first 30. It's very redundant because it's repeatedly calculating a lot of information. So this is too slow. Let's profile it and figure out what makes it tick and why it's so slow. Now, one note here, I'm leaving time on there because this is going to be a lot slower. It's no longer going to take 2 seconds because there is a lot of overhead of NYTProf. So you definitely can't just leave this hanging around in your production code in case you wanted to go profile something later on. It's definitely something you need to turn on and off as needed because we're still not done yet. And it adds a lot of overhead. So 20 seconds. So 10-fold pain in this particular case. That's not universally true. This one is really, really highly recursive, and that's extra painful for NYTProf and just Perl in general. But don't leave it running. Just use it as you need to. However, NYTProf tries really, really hard to keep all of that extra time out of the timings that you get for your code. So hopefully, given the various non-determinism of using wall clock to try and time things, hopefully NYTProf doesn't affect your code too much. So let's actually take a look at what that gave us. So now we've got an NYTProf output file. Yeah, that's. Can somebody tell me what's going on? Oh, no, that's not gonna work out very well. So let's just run NYTProf HTML. I can be lazy here because I didn't do anything special with the naming. This is also going to take a minute because, again, Yeah, 7 million subroutine calls happened in my massively, overly recursive call. But this is running through that huge NYTProf output file, parsing through all of its outputs of all the timings at each statement, each subroutine, each block also, which is convenient and useful at times. It's handling Perl opcodes in a way that I'll show you in a little bit that's kind of nice. So that is, more specifically, if anything your profiling happens to call out to XS, which might be a lot of core Perl, or if you're using, say, DBI or something like that, where portions of it are in XS, then it has kind of special handling for that. It can't actually really show you the profiling inside of your C code somewhere that got compiled away, but it'll give you at the outside. The NYTProf, let's, oops, a lot of fat fingering there. Let's see what we got. 23 megs. It's not enormous. So now we've got this NYTProf directory right here. And we need to do something with that. We need to get that somewhere. So on my, this is just all on my laptop too, but let's move that to nytprof.fibonacci.slow. We'll call that one. Oops. Yep, permission. Oh, you all saw my password, dang it. Okay, so then let's go. No, that's not it. So, nytprof.fibonacci.slow. Okay, so this is the starting point for, is that legible to everybody?
No.
There we go. Woo. Okay, so depending on which version of NYTProf you're running, you may get this flame graph. This is pretty cool. In this particular example, it's kind of boring because it's just one thing super recursively, and so you just see the same dumb method over and over again. But it has a link explaining what flame graphs are and how to interpret them. And here, yep, there we go, is a much better example of what you might be seeing. So this is your code over time, and it's not everything 100% of what's happening. It's doing sampling to see where you are in your call stack at certain determined intervals. And so then it shows you your call stack basically at equal intervals over time. So it's kind of attempting to be a snapshot. It's almost like you're watching your little CPU graph happening in whatever monitoring app you have, except it's showing your call stack on top of that, which is kind of cool. So the next piece it shows you is a breakdown of the worst subroutines that your code ran. And this has a number of different pieces that I'm not going to explain everything to. You can read the documentation. You can explore more. But the really key things here are number of times your code was called. The exclusive time is how much time did that subroutine take itself with just the code that's in it. And inclusive is obviously inclusive of everything else that it called. So the inclusive time is overlapping time. Exclusive is theoretically non-overlapping time, although recursion gets more complicated because everything's overlapping. So this took about 16 seconds according to NYTProf, which you'll notice is not the 2 seconds we timed it before. So there's a little bit of complication there. That's really just the effect of the recursion in this example. And then a handful of core things and just warnings and strict. There was really not much else in my code to profile in this example. I'll show you a more complicated example later, but wanted to play with the toy one just to start. And then there's a breakdown just to slice it a different way. This is by your source file, so that you can see, maybe you didn't spend a whole lot of time in any one particular method, but you did spend a lot of time in one file. And you can kind of see where that's going on. And this will profile all of the code that got run, whether it's yours or just a bunch of CPAN modules you're running or whatever it is. It's everything that got run while NYTProf was turned on. So you can see all of the paths and all of the files. And it can be really useful, especially when the pain point is not actually you, but something you're calling out to. So the first thing I always do when I take a look at NYTProf is I jump to this page. So that link, if you can't see it, says all 26 subroutines. Usually has a much bigger number. And then you see basically the same thing. In this case, I had so few, but in the other view, you'd only get the top 10. This one is going to be everything that happened. And you can play around with it, and you can sort in this view by, say, exclusive or inclusive time. I almost always start with inclusive time, so I can kind of see the flow, because the first thing you ran is going to be generally the biggest, and then each thing that it ran gets sliced down smaller and smaller. Now, the real fun part is that you can then click on the method that was slow, and now you're actually in your code, marked up and annotated. Again, this is Devel covers output, basically, but with some extra additions from NYTProf. So up here, you can see for the slow Fibonacci subroutine, we spent 16 seconds running that. It was called 7 million times by itself, and it was called 30 times by the main runtime. That breakdown of where the calls came from can be really, really useful. Let's say that you're looking at code that looks up a record from a database, and you notice that it got called 5 different times from 5 different places, but it's not caching anything. So each of those 5 times, it had to look up that exact same record from the database, and that is a portion of why your code is running slow. So even though you can't see in here the actual data, you're only looking at the code and the timings. You can't see what the data is that's getting passed around. You can, if you know what your code is doing in general, if you know the kind of data it's working with, you can make a lot of interpretations from this timing data to say, oh, hey, I could totally optimize this by just caching the output of this method and returning it next time with the same output. So then, let me point out here, we really did not spend 300 seconds making millions of recursive calls. That's a little bit of a breakdown in NYTProf's timing. It tries, but it's not perfect. You kind of see the disparity here. This 0 seconds should be total time it spent in the calls that it's making out. It tries to subtract out its recursive time, but yeah, it's not always perfect. So down here is a little bit more accurate. You get the 16 seconds that this actually spent calling, making the 30 calls there. And it tried to reallocate the time to where it thought it really came from because of all the recursion. Yeah?
How was the color coding determined?
That's a good one. So the color coding is all based on default timings that is in the code. You can tweak that yourself. You can say how many calls you think is too many, how many calls you think are, or what kind of timings are too slow. This is such a slim number of examples. You only see the green and red, but there's shades of orange and yellow and whatnot, depending on various thresholds that the code has built into it that you can tweak with. I've generally not, because I've generally found that red means bad, and it means bad to me. But if you have a particular use case, you have code that this piece is going to be slow or something, you can tweak with those thresholds a little bit to change the coloring.
One thing I've noticed is as you clean up a particularly bad thing, say that thing now would have gone from red to green, something else that used to be green may now become red because it's looking at what is the worst, not looking at what is the threshold of pain. Does that make sense?
Yes, absolutely. So, and if you scroll up, there's actually kind of a table of contents here of all of your methods, and every single line that not only does something but calls out to something else will have these additional little comments kind of embedded into it. So you can see the breakdown of I spent this much time on this line, I spent this much time calling out to whatever it is that I went to go do. So let's actually make this faster now. Oh, hey, look, Ubuntu wants me to update. Let's do that later. OK, so I think I probably left it open. Yeah, Memoize. Memoize is a great solution for the particular case I talked about. In this case, and actually, Memoize would be a great solution. Well, a solution, probably not the fastest solution here, because when you're doing recursive Fibonacci, you do the exact same math millions of times over and over again. It's very redundant. But you can do Fibonacci in an iterative way with just 3 variables here. Google it and you'll find lots of equivalent ways and lots of languages. So I just changed this down here to be fast Fibonacci, and now we can see the improvement. So now we'll time the fast, which is, a lot faster, and then we'll time the we'll profile it while we're timing it. And now we're still, even with NYTProf, faster than we were with the original code. Oh, boy. You spelled Perl wrong. Yeah, I did spell Perl wrong. I still can't spell Perl. Yeah, live demos. Hey, still faster. It's good. It's funny. Did that brick over your... Oh, no, you moved that. It did brick over the NYTProf.out, but I moved the directory, so that's not there anymore. You'll also notice the NYTProf.out is now 8K instead of 23 megs or whatever it was before. Just there's a lot less data. So NYTProf HTML, that took a lot less time. And now we've got the directory again, and we'll get that somewhere useful. This time it's faster. Oh, same mistakes over and over again, right? OK, don't need that anymore. OK. Even simpler flame graph, now with a little bit more bits, because in its little intervals, it wasn't just spending all of its time recursively digging. Now the fastest or the slowest part isn't even the thing that we were looking at before. Now it's just the setup and teardown of the code. But we can dive in and we can look at the fast Fibonacci, and now got a little bit more color here. This one took 88 microseconds, which is not quite green anymore, but not quite red. Only 465 times inside of this loop, which is a lot better than 7 million. And some timings down here, which are about the same, except that this is now 442 microseconds instead of 16 seconds. But we still get the breakdown. So 224 microseconds calling printf, and 218 microseconds calling fast Fibonacci. And I forgot to mention it before, but this is what you get when you call out to something that is compiled XS. You just get a name of a subroutine, as best as NYTProf can pull it out of somewhere, and just says opcode. So there's no actual code you can profile here, but you do get still the breakdown of how much time did you spend in that code, and where did it get called from, so you can kind of see. If you have, for instance, you'll see a lot of this if you're working with regular expressions. The substitution or just matching methods are all compiled XS. So you'll just see a line here, but you can see every single place where you did a match with a regular expression and how long each of those pieces took. Because the breakdown by times, where it came from, also shows you line number, and all of this is all hyperlinked together, so you can go and trace to your other code, and then average 7 microseconds for everything that got called from this particular location. So if there's 50 different locations that are calling this line of code, each one will have a similar breakdown. So now let's look at something that's not. Yeah, go ahead.
So on this, how far out is it? If you're including a bunch of packages, say DBI or whatever, is it going to generate a page for each of those and reach way into the internals of all that code?
Yep. Up until you get the Perl XS boundary.
This is a non-toy example. We are working with Freeside, which is open source billing software tool. It's all written in Perl. And this is actually the profiling of a call into that. And in this case, I did actually, because it's talking to an API, I did actually do the DB start profile, finish profile within it. So this is only a slice of what was going on. And this is everything that it profiled. And there's only one module of my code buried in here, and I don't even think it's on this screen. Nope. So this is all FS is Freeside, DBI. I hope you all know DBI. And the code that I'm actually profiling is way down here, because my code doesn't really do much more than call into Freeside. And so I'm actually debugging somebody else's open source, well, not debugging, but profiling somebody else's open source code right now. And to answer your question, yes, every single one of these methods is hyperlinked to another page that will show me their code and the breakdown. So I've got it already pre-sorted here by inclusive time. And let me show you the cliff notes. 2.29 seconds. Little tweaking got 1.67 seconds. Little more tweaking got 2.3. Not improvement. Doesn't always go the direction you want it to go. Undid that, tried again, 834 milliseconds for the exact same piece of code that I was running. And 834 milliseconds doesn't sound like a lot, but for the purposes of profiling, I ran this outer order packages on 3 things just to get some information for profiling. I need to run this for over 1 million customers and get it to finish, this week. So 834 milliseconds is well, the 2 seconds I started out with was way too slow. 834 is still too slow. I did get to 768. I don't think I got any better than this. But there's, you'll notice, let's see, nope, that one's not better. You'll notice that the last thing that it's really left, as some of the bigger things have fallen off, the last thing that's really left here is this FS record insert. FS record is basically Freeside's ORM. And all this is really doing is a database insert into the database. So now the key, I've basically stripped away all of the pain except for the database insert, which is the thing I really can't get rid of. And since I have to do tens of millions of inserts in the code I'm working with, I am stuck to some degree with just slowness. But I cut it by more than half just by using NYTProf. So let's look at how I actually managed to accomplish that. So the starting point for me, and you're welcome to look at the exclusive time, but the exclusive time for me quite frequently ends up being something like DBI, that I'm just not going to be able to beat out that. So I need to look at, do I really need to call this execute 299 times? That's often the thing that's most useful. Or, do I need to, are there other places where I can avoid doing work that I didn't really need to do? So I'll start with the inclusive time, and I'll start drilling down. And you can do this even in code that you don't know, because it's all nicely color-coded. When I first looked at this, I didn't actually know what any of this code was doing. This was just total gibberish to me, other than knowing Perl. But I just scrolled down until I started to run into some red. And I said, hey, red code. That's bad. So of the 2 seconds I spent in here, a bunch of it was spent doing other bits of things, but 1.67 of it was spent on this line, but not really anything here, but really calling out to this insert. So from there, notice this one is also a hyperlink. You jump down, and you can really follow the rabbit all the way down. And now we're looking at here what's going on with this code. So this insert is inside of an ORM, so it's more than just stick it in the database. There's some sanity checks going on, 870 milliseconds. That's the bulk of it. Little bits of other checks. Let me make sure that my start dates are refilled if they didn't come pulled in or whatever. You can look at a few other things, but really the bulk of what's going on here is right there on that check package part. So let's just keep following the rabbit down that hole, and we end up with check package part. And what's going on? Well, we're pulling in this agent num. And in Freeside terminology, that's basically the ID for the agent talking to the API. So there's a lot of my pain. But the first thing I noticed, even though I don't really understand all of this code, is unless disable agent check. Hey, I know who I am. I'm controlling this whole thing. I don't need to sanity check my agent because I've already done that externally in some of our API code. I can just flip that variable wherever that is, figure out what that option is, and all of a sudden I don't have to do these sanity checks that are hurting me so much on this import. So that kind of optimization is what you're often going to end up with when you're using NYTProf. Because somewhere deep down in the code, there's something like a database insert or a call out to a third-party API or something like that that you just can't do anything to speed it up. But you can slice off pieces of code that weren't really necessary for your use case. You can add more checks. You can add more caching. You can say, you know what, I don't really need to call that code 30 times. If I just shove the output of the call into a variable and then I don't call the code 30 times, then my code will be the wasted time in my code will be eliminated, and I'm just boiling it down to the painful bits, the DBI inserts or the API calls out to whoever you need to talk to for your code. So that's a little piece of what I actually ended up doing in here. There were some global variables that were useful for insert cases, and if we go, how much time do I have? I'm probably
About 15 minutes.
got plenty of time, right? Okay. So let's go actually look at the change. Nope, that's not it. Nope. There we go. So this came from that. Okay, so this is actually a little slice of the code that I was running. You can see my enabled profile turned on right there, and some of the various pieces that are getting executed. And most of this is sanity checks, but then right there is the actual insert call that's actually happening. So, and this is in the final version of the code. So you'll notice a couple things. A minute ago, I'd traced down through this order packages method that FreeSide had. I'm no longer even doing that in this code, because what I did is I looked at what that code was doing and I said, I don't need to do all of the sanity checks and all of the pieces. So I ripped out the core piece, which was actually making the insert and making that happen, and I just stuck it into my code. That's an optimization I could make in this case. That's not always going to work, but that worked perfectly for me. I also found 2 different flags I could turn on within that code to skip some pieces. And obviously, I don't want to explain all of FreeSide to you, but skip some sanity checks and say, this is an import. And I actually made some changes. And let's see, do I have that tab open? Yep, here we go. So this is GitHub. And these are some of the changes that I pushed up to the FreeSide, the actual FreeSide package, that it was doing all of this code. And you probably can't quite see it down there at the bottom, but I just wrapped a if import around a whole bunch of things and said, don't do all of this stuff that I don't need. And I pushed that up to the open source package, and the patch got accepted, and it's now actually part of FreeSide. So I got to not only optimize my code by changing the methods that I was calling into FreeSide and changing exactly how I was using it, but I got to optimize their code as well, because NYTProf showed me the whole big picture, and I could see where all of the pain points and bottlenecks were for the use cases that I had. So, oops. There we go. Okay, that is basically the gist of it. So we'll just jump back in if it works. There we go. Any questions?
Now everybody's reading it.
Yeah, of course. It's XKCD. Why wouldn't you read it? Nothing? Okay, well, as I said, for any of you non-Bluehost folks, I've got some free VPS cards, VPS and Dedi up here. You're welcome to come grab one from me. If anybody has any questions afterwards, just find me. Probably be at the Bluehost desk, and that's it.